quiz. Okay, so let's finish that the binomial case first. We talk about the binomial distribution is the case that you are going to have only two outcomes. Okay, the situation is going to be one of the outcomes, we are going to call it a success. The other one's going to be called a failure. Okay, it's something that you repeat it over and over. Those repetitions are going to be called trials. So like tossing a coin, 50 times, 100 times. Then there are two possibilities. The one's going to be on favor. We are going to call it success. The probability of success would be denoted by P. And on the opposite side, you are going to have a failure. So Q would be probability of failure. And since there are only two possibilities, so Q is 1 minus P. N is going to be the sample size, the number of the times that we're going to experimenting this procedure. And the X is the number of successes. In some books, they denote it by R, and I prefer the R. But we just go with your notation. And the PX is going to be probability of getting X successes out of N trials. So a situation clearly would be given to you. These type of statements always start with a, it's known, it was recorded, a kind of percentage would be given, and they ask you a question, which is going to be 3 parts. You are going to design the problem and you get the result. Let me give one example to see how we're going to take care of the binomial distribution case. Okay, any question? So get this formula: P probability of success, Q probability of failure, X the number of successes, and the total number of tries or sample size. So let's just give you an example, then you realize how we're going to apply this formula. Okay, so the situation is, example, is always start with something, a fact that's going to be given to you. It's very easy to identify that it is a binomial case. Now the fact is, it's known that, okay, it's known that there is 80% chance. Okay, 80% chance that a person age 20 now will be alive at age 65. Okay, will be alive at age 65. So that's something known. So if the person, in a minute, you will find out that we are going to call it a success if a person would be alive at 65. So that's a fact. Now they're going to pick a group of people and they ask you one question. They pick a sample. So the sample is going to be, suppose that 3 people, okay, suppose that 3 people age 20 are randomly selected, randomly selected. So your sample size would be 3. So what would be the question? The question is, would like you to find this probability. They ask you 3 questions. Find the probability. Okay, find the probability that the number of, okay, the number of alive persons, okay, number of alive person at age 65 will be. So we want to check out of these three people, they are 20 years old, and we want to know the following numbers are going to be alive at the age of 65. It's going to be three parts. The first part, they go with the exactly 2 out of those 3 would be alive at the age 65. That's the first part. The second part, they go with the expression at most. At most 1% would be alive at the age of 65. And the part C is going to be at least 1. It's always these 3 expressions that we're going to use, okay? At least 1%. So this is going to be a situation that we are going to have. Okay, as soon as you read this, you realize this is a binomial distribution. Because if you pick a person of 20 years old, there are 2 possibilities. That person would be alive at age 65 or not. So it is a binomial case. When it's going to be a binomial case, you have to identify what are you going to consider to be success. You are going to be considering success in this problem, the fact that the person is going to be alive at the age of 20. So the probability of success is 80%. So you have to connect this percentage to your problem that you're going to have, okay? So that's a very important part, that we realize that it's a binomial distribution, easy to realize because there are 2 possibilities, the person would be alive or not. So what are going to consider to success? The success is the person is alive, the probability is 80%. So P is going to be 80% or 0.8. As soon as you identify the P, you can have the Q. Q is the opposite complement, 1 minus P. So Q would be 20%. The probability that person is going to be dead. The sample size is equal to what? 3. So quickly you should identify these 3 terms when you read this problem. Okay, so the solution is going to be, I'm going to explain it that it's a binomial case. Okay, it is a binomial distribution. Is a binomial distribution. Binomial distribution with the following information. You identify the P. P is equal to the 80% probability of success, or equal to the 0.8. Okay, that would be the P. The second one is Q. Q is 1 minus P. Okay, Q is 1 minus P. In this case is going to be 2%. And the sample size N is equal to 3. So you have to identify these 3 notions when you're dealing with this type of problem. Okay, so the unknown is going to be the number of success, probability of getting X number of successes. Okay, so this is going to be the design of the problem, and you can write your formula if you like, you know, the formula that we did have. Okay, what was the formula? The formula is P of X is equal to the N factorial. Okay, N minus, okay, N factorial, N minus, in this case is X, you know, it's got to be R, but in your book it's X, very bad notation. We go with that one, minus X factorial times X factorial, and this is going to be P to the, okay, P to the X, Q to the N minus X. This is your formula. Okay, and in this case, what you have is, you see, in your case, is a P of X equal to the N is equal to the 3, so it's going to be 3 factorial, and this is going to be 3 factorial minus X. Okay, sorry, N is equal to the 3 minus X factorial, your P is 0.8 to the X, Q is 0.2 to the 3 minus X. And this x can go from 0, 1, 2, and 3. That's a general formula. It's the first problem, so I give you all the details, but we are going to summarize it. Okay, now we read the problem. What do you want? You have part 1. You see in part 1, you want to find the probability that you get only 1%. Probability that exactly 2% would be alive. So you want to find what is the probability that x is the number of successes, the people to be alive, to be equal to what? To be equal to 2. So you are interested in P of 2. P of 2. So you go back, you substitute x equal to 2. So P of 2 is going to be equal to 3 factorial divided by 3 minus 2 factorial times 2 factorial times 0.8 to the x is equal to 2, times 0.2 to the 3 minus x, 3 minus 2. Okay, now 3 factorial we talked about the other day would be 6. 3 minus 2 factorial is just 1 factorial, okay, which is 1. 2 factorial is 2, times it by 0.8 squared, times 0.2 to the first power, because 3 minus 2 is 1. Now 6 half, that give you 3. That would be 3 times it by. Okay, that give you 0.64 times 0.2. So it's going to be 3 times 0.128, and the result would be, okay, the result would be 0.384. So the probability that 2% would be alive at the age of, okay, age of 65 is going to be 38.4%. And then you're done. Any question? Now, of course, you see this number was easy. If this number is getting larger, it's not going to be easy to find. I mean, it can be found, you know, if you have a very good calculator. But you have 2 options. Okay, 2 options. One of them is the table that I posted for you. I'm going to explain that table first, then the calculator. Okay, are you done? So I show you the paper, how we're going to do it. You see, this is the table that I posted for you. In that table, this column over here, you see the column, the first column would give you the n, the sample size. This is going to be the n, and it starts from, you know, start from 2, 3, 4, 5, 6. The second number is r. R is x. In your book, very badly, the notation that they use is r is x, but this is going to be r. Okay, so it's going to be your x, number of successes. So when is equal to the 2, the possibility for r or x is going to be 0, 1, 2. When n is equal to 3, the possibility would be 0, 1, 2, 3. Okay. So the first column would be n, the second column would be x. This top row, this is p, probability of success, probability of success, probability of success. And these numbers are exactly the probability that we've been looking for. Now, how are we going to use this table? You see, the way you are going to use it is you identify your n first. You see, in this problem, n was equal to 3. Okay, n equal to 3. This is n equal to 3. Then your r or x equal to 2. That is 2. Okay, so n equal to 3, r equal to 2. Then you move to the right and you match it with the p number. Remember the p was 80%. So if you go on and read the 80%, 80% when r is equal to 2 is 0.384. 38.4%, and this is exactly what we did. Okay, you identify the n first, n is equal to 2. If we write it down here so that you know how we pick this one. This is the way you do it using the table. For the table, you pick the n first. N is equal to 3. N is equal to 3, but your R is what? Your R is equal to 2. Your X. X is equal to 2. You move on and you match with the first part, that P. P of 80%. Okay, 80%, which was 0.8. And you read this number. The number is 0.384. So that would be exactly P of 2. P of 2 would be 38.4%. And that's exactly what we got over here. Any question? Very easy to do this one. You are not going to do this type of operations. You just identify the P, Q, and the N, and then the part of the problem, and then be done.
Professor?
Okay? Yes.
So why would we need to solve all this if we find out the P and we find out the X, we can just use the chart, right?
Of course.
Okay.
That's
But you're just showing us how to solve it if we manually?
Yeah, otherwise you don't accept it. You see?
Okay.
No, it takes quite a while if you want to do all ultimate calculator. No. And that's just part one of the problem. No, we need a chart or calculator. Let's show you with the calculator. The chart is very much more useful for you because the calculator is also nice, but you are going to see that the calculator give you one reading. Sometimes you need more. So try to do both of them, but it's up to you. So if you want to do it with your calculator, okay, this one can be done, or the other one that I have. Okay, both of them give you the binomial case. In order to get to this one, you are going to turn it on. Then you have to go to the distribution. Okay, this is it. This is the distribution. DISTR, distribution. That's you get the variables. Okay, if you get the variables, that's better. This is going to be where we get the distribution. Okay, that's the distribution. So what we are going to do, we are going to the second. Okay, second. And then we click on the distribution. When we get distribution, these are what you are going to see. These are various distributions that we're going to use in future. This is the normal. You have to go down to get to the binomial. Okay, if you go down, I think it's number 10 maybe. We're going to use all of them in future. Yes, this is it. Okay, this is binomial. Okay, binomial PDF, that's the one. So what you're going to do is now you're going to click on this one. Now you will see it. You see for the binomials, the first part gives you tribes, the number of the tribes. The second one is the P. The third one is the X, and that gives you the result right away. So in this problem, N, the number of tribes or sample size is 3. So I'm going to change it into 3. So that's going to be number of the tribes. Okay, then you go down, you identify the P. The P was 8%. So I'm going to change this one into the 0.8, 80% or 0.8. Okay, the number of the values X. X is 2, so it's the same number. So I have the 2 here. It's a paste, that would paste your result. That will tell you this is what you are looking for. Okay, so the sample size of 3, the P 80%, and the 2X. Then you click to get your result. You see that give the result, 0.384. Any question? And if you have more, you have to add and just continue to get more numbers, more cases. Okay, so this one would be also very useful, very easy. Okay, so you go back to I just do it again. You have to go to the second distribution. Okay, you move down to get to I think it's number 9 or 10, to get to the binomial. Okay, you see, this is binomial. And then you click on the binomial. Then you identify the trials. N, P is the probability of success. And okay, X is going to be the value, which is 2. Then if you do all of them, that will paste it for you and then give you the result, 0.384. Okay, that's going to be the one. But since you are going to have several readings, the table would be quick. I'll do both of them, you see. That's part one. Part one, you are going to have one reading only, because this is exactly one. Any question? So decide what you want to do. You have to do it once on this test and twice later on, and of course once on the final. So that's the first part, exactly two. They give you three expressions. The second one, at most one. Remember, at most means the end. We talk about it. At most one, you are going to have, this is the way you're going to write it down. Okay, going to the part B. Part B, at most one means the probability that the number of successes is going to be X less than or equal to 1. Okay, this is what you are interested in. At least the starting point, at most the end. Now you break it, but the possibilities, you see X less than or equal to 1. You know that the possibility X is 1, 0, 1, 2, 3, etc. So the possibilities are going to be P of 0, okay, P of 0 and P of 1. Again, you can go to your calculator and find each one of them separately, or the table is much easier. You go back to your table. You see, this is what we got over here. You see, that was a table. Remember, n was equal to 3. N was equal to 3. That's n equal to 3, 1, 0, and 1. This is 0. Okay, in the case of the 0 and 80%, 0 and 80%, that give you 0.008. 008. This is going to be for P of 0. And if you go down, that give you P of 1. P of 1. 0.096. Okay, you add them together. Okay, so for the 0.008 and 0.096 is going to be the second one. So this would be equal to the 0.008. You can use your calculator to get it right away. Plus 0.096. You add them together and that give you 0.104, which is 10.4%. And we're done. If you want to do it with your calculator, you have to do it twice to have to change those numbers to be able, to get it. Okay, any question? If you want to do with the calculator, you have to change it, the number of the successes. You see, that's going to be when this table would be easier. So this is if you want, but the table is much easier for this one. So this is going to be your calculator. So the number of the trials, you see, you have to have the 0 and 1 in this case. The number of trials is 3. That's going to be 80%. So you have to change the X into the 0 first. And that would be 0. Okay, and then you go down and you paste this one. So that gives you the first one, which is 0.008. Then you have to add it and then continue again. Okay, this is maybe other way to do it, but this is the way I do it. So then you have to change the X into 1. Okay, X into the 1. Then you paste it, and that give you the second one. You see that give you the second one. It's a 0.08. You add it, and the result is 0.104, which is 10.4%. Okay, so just pick the one that you like, the table or the calculator, to be able to do it. Okay, any question? Make sure don't miss it. It's at most less than or equal to. They usually give you 3 cases, at most, at least. So we have another part. The other part is going to be, they ask for the at least one. At least is the beginning, so P of X is going to be greater than or equal to 1. and greater than or equal to 1 means 1, 2, 3. So probability of x greater than or equal to 1 is going to be probability of x equal to 1, x equal to 2, and x equal to 3. So we need P1, P2, P3. Okay, again, you go to your table, easily you can find it. That was n equal to 3. You want the 1, 2, 3. You see, this is going to be 1, 2, 3. That's it. In the case of the 1 is a 0.0996. In the case of the 2 is a 0.384. And in case of 3 is 0.512. You don't have to write it. You just look at this and you add it with your calculator. You see, you have 0.098, 0.384, and 0.512. You add them together, that gives 99.2%. Okay, any question? So you add the resultant number here. Okay, so P of 1 is 0.096 plus, and you get a 0.384, and you get a 0.512. You add them together, that give you 0.992. So the probability that at least one of those person would be alive at the age of 60 would be almost 100%. And that's true. At least one of them is going to be alive at that age. That's it. Any question? So it's very easy to operate with the probability of binomial one. The disadvantage of that table is that the table gives you up to the n equal to 20, not a larger number. And there is a reason for it. We have something we call it approximation in future. We're going to approximate really this one in future. But anyway, it's available and you can use it. So table or your calculator. Don't try to calculate it because it takes quite a while to be able to do it. Okay, any question? We have 2 on the practice test. We are going to do it right away to make sure we have, you are familiar with this method. And there is another, there is a formula for the mean, standard deviation, the variance. We talk about it after your test. So we just check this one only. Any question? So let's go to that practice test and get those 2 that related to the binomial one. Okay, so this is the one that I posted for you. So where is that? Got it here. Yes, practice test number 2. Okay, so I'm going to show you. So I will write the detail and we come back and we continue. And so okay, can you see the practice one? So this is the one that we are going to consider. There are 2 problems, problem number 10 and number 11. Okay, this is it. This is going to be problem number 10. The situation is that if the first one, if 80% of the people in the community have internet access from their homes, find this probability for the sample of 10. So quickly you identify that this is a binomial case. Okay, it's going to be binomial case. Success is going to be that you have an internet access. So probability of success would be 80%. The failure was 20%. We don't need it, of course. So the sample size is going to be 10. Okay, we pick 10 people, and then we ask this question. Exactly 6 means P of 6. At most 6. Sometimes these numbers would be different, but in this case, they are all the same. Okay, so it's going to be exactly 6, at most 6, at least 6, and at the end, which one is going to be more likely, likely to happen. So I go back to just checking some of these numbers, so save sometimes. to get this number down if I have them. Yes, this is going to be the case. Okay, so I go to my lecture notes and explain it. It's just a rereading again, a little bit more reading, in fact, for this one. Okay, so this is a question number 10, so that's a practice. Okay, practice test, and number 2, and we're dealing with the question number 10. So the situation is having internet access. So again, you are going to explain it that it is it is a binomial case. It is a binomial. You have to explain it, this part, of course. Binomial case or distribution with, you have to give us 3 numbers. The numbers are probability of success going to be 80% again, which is 0.8. Okay, probability of failure is going to be 20%. We need this one for other purposes in future, not now, because we use calculator. And the sample size n equal to 10. Okay, n equal to 10. So the question is going to be P of X. You don't have to write the formula. So we have 3 cases. The first case, they ask for the number of the, okay, the number was exactly 6 home would have households would have access. So the probability, the first was probability that X to be equal to the 6, or you would like to get P of 6. Okay, calculator, or you go to the table n equal to 10. Okay, identify R equal to 6, and then look at the what? Look at the P equal to the 0.8. Okay, 0.8. And as we did it for the other one, you see this is going to be the case. Your P equal to the 6 is here. Okay, so there's going to be P equal to the 6, and sorry, n equal to, sorry. What is the n? The sample size is 10. So I should bring the 10. That is the 10. Okay, n equal to 10. But your X is equal to 6. So 10, 6. That is going to be 10, 6. Okay, 10, 6, and the probability of 80%. If you go with the 80%, that gives you the number 80%. 0.088. Okay, 0.088. Any question? Which is 8.88%. Okay, so you get this number, and this number is going to be 0.088. So the answer is going to be the probability that exactly 6 people would have internet access is going to be 8.8%. And we're done. Any question? So quickly we can check it. Okay, get a copy of your table if you want to use it. And if you want to prepare your calculator, make sure your calculator is ready. That's the first part, question. The second part, they ask for the probability of at most 6. At most 6 is the end. So the probability that X to be less than or equal to the 6. Okay, so less than or equal to the 6 means 0 up. Okay, 0, 1, 2, 3, from 0 to 6, or from 6 to 0, whichever you prefer. Okay, so this is it. The probability of X to be less than or equal to the 6 means P of 0, P of 1, P of 2, P of 3. Okay, P of 3, and P of 4, 5, and 6. 5 and 6. So you go back to your table. Okay, you start from 0 to 6. It would be easy to check this one. You see, look at the table that you have. That was your 10. Okay, 10, you want to 0 to 6. You see, look at this one. This is 6, 0 to 6 and 80%. 80%. You see these numbers? This is P of 1, P of 2, P of 3, P of 4, 5, 6. 0, 0, 0, 0.01, 0.6, 0.28, and 0.088. You don't have to write it down. You look at these and you add it with your calculator and give us the final answer and be accepted. Okay, so I write a couple of those numbers so that you know what's going on. So as you can see, these the first three was 0, so we get a 0. And what I got over here, it was CP of, in the case of P of 0 is 0. Okay, the first 3 is 0. So we get 3 zeros and then you start with the numbers. Okay, this is going to be 3 zeros and you start with the 0.08. Again, you don't have to write it. I just write so you can check it for yourself. And these are going to be the numbers that I have. So if you add them together, and that would give you 0.121. So the probability that at most 6 households would have an internet access is going to be 12.1%. And be that. Any question? So remember, at most means the end to get these numbers. There are a different way to do it. Sometimes the complement may be helpful. You see, x less than or equal to the 6 is going to be the same as x to be greater than 6. So greater than 6 means not for this one. That give you you can have the 7 up to the 7, 8, 9, and 10. That give you the same thing, but the numbers are very limited. You have the calculator and the table, so that give you the result right away. Okay, so this is going to be at most question. Now we are going to have at least. So it's going to be the at least. There is always 3 cases. At least 6. At least 6, you will start with the 6 and you go up. So it's going to be 6, 7, the sample size is 10. So you have to go up to the 10 this time. Okay, so the probability x to be greater than or equal to 6 is going to be probability of 6, probability of 7. Okay, 6, 7, 8, 9, and 10. So you already got it on the table. You just add them together again. You see, you have when you see this one for your test, you highlight the column of the 80% because you are going to be in this column in this problem, and you come back to it. You see, it's going to be 6 up to the 10. It's the leftover here. So that would be the leftover. You see the 6, 0.088, 7, 201, 302, etc. The leftover. Just add them together. Okay, or you can find the complement of the other one, which is going to be the same thing. So this is it. That gives you 0.088, the first number, plus again, check it with your calculator and add it as is. We accept it. I just write it so that we can check it. It's going to be 0.288. And for the 10, we have a 0.107. And if you add these numbers together, that give you what? That give you 0.967, which is 96.77%. Okay, so the probability of getting at least 6 households having internet access is going to be 96.77%. Okay, any question? So it's a very easy problem, really. They ask you to compare them together. Which of these are most likely to happen? Okay, So as you can see, for the part C, 96.7% chance. The other parts, you get 80.8% and the 12.1%. Of course, case C, the chance that would happen is going to be case 3 because it's 96.7%. So to answer the part D, okay, to answer the part D is, you can say that case C is most likely occurring. So that give you the result right away. Very easy case. Okay, any question? So what is this one? You know, 90, do we have 98? No. Is it 98%? You can check it with your calculator. The last one, I think that's one, can check it to see if this is going to be correct. I haven't checked these numbers. If you added, get 98.6%, okay, just check to see if it's going to be the same. 98.6%. Maybe I made a mistake with the numbers. Okay, so this is going to be a binomial case. Any question? We have one more. We can do that one too, just to make sure everybody understand it. And you can't miss this one. The only part that you may miss on the test is at most, at least. At least is the beginning, remember. At most is the end. So make sure you get this one right. Okay, we have another one, an easy one. We check that one too, so that we make sure that we have no difficulty. Okay, so getting back to what we just give you the problem again. You see this number 11. Number 11, the situation is that this is number 11. So what is that? It was found, you see, all of them start with this type of expression. It's reported, it's known, it was found. It was found that 60% of Americans think that having a college degree education is important to succeed in business world. If a random sample of 5 Americans is selected, find this probability. Exactly 2 people agree, at most 3, at least 2. Okay, so you have to design it. It's a binomial case because there are 2 groups of people, the people who agree and the people who don't. So if you agree, this is going to be our success. So P is going to be 60%. Okay, and the sample size that we have is 5. Okay, so it's going to be a binomial case. Okay, this is going to be the one that we have. So I go back to my notebooks again and get this one done. Okay, so that is a binomial case again. Okay, we explained that it is. Remember, you have to identify these 10 for us at the beginning of your problem. Don't just give us the number. It's a binomial case or distribution with, you have to identify a probability of success. Success is 60%, which is a 0.6. So the failure would be 40%. Again, we are not going to use it for this problem, but we write it down. And the sample size that we pick a sample of 5 Americans. Okay, that's going to be 5. So what is going to be the first part? The first part, we want to know exactly 2 people. So part 1, you want to find the probability that X to be equal to 2. Okay, X equal to 2. So we are interested in P of 2. Okay, so again, you go back to your table. Okay, for N equal to 5. So this is going to be N equal to to 5. Okay, so we have the n equal to 5. Let me write down for you. What you are looking for is going to be, this is it. N is equal to 5. Okay, n is equal to 5. We go back and we get the x is equal to 2. So you go and look for the probability of success of the what? 6%, 60%. P equal to the 0.6, and you read this number. Okay, 5, 2. This is what we have. This is n equal to 5, x is equal to 2, and you go for the 60%. Okay, if you go for the 60%, the number is going to be 0.230. Okay, that's it. This is 60% on the top. Okay, 60%. And your case, n equal to 5, x equal to 2. So that give you 2.3%. Okay, that give you 0.23. And so in this case, the probability in question, the P of 2 is going to be equal to the 2.3%. And with that. Okay, that's going to be case 1. Any question?
Professor, do you always give it in as a percentage and never leave it in the decimal form?
Yeah, percentage is better.
Okay,
Decimal would
thank
be
you.
also fine. But since the probability of success is given to you in percent, so you have to give the answer in percent too, because you compare it with that number. Okay, but we accept it even if it's going to be decimal. So this is going to be the first part. Okay, the second part, at most 3 people. Okay, at most is the end again, so probability of x to be less than or equal to 3. Okay, that's going to be the at most 3. Okay, so again, we know that at most 3 means we have to start from the bottom. So probability that x to be less than or equal to 3 is going to be probability of 0, 1. Okay, 0, 1, 2, and 3. That is going to be the case. Okay, just go back to your table and you identify these numbers right away. Okay, going to the one that we design, n equal to, okay, and just pick these numbers, n equal to 5, say n equal to 5, then we want up to the 0 to 3. Okay, that's it, 0 to 3 for the 60%. Okay, you have 4 numbers. You can add these numbers with your calculator right away. Okay, it's going to be 0, 0.01, 0.077230, and so just write it down. So this is going to be the cases that we are going to have for the 60%. So I don't have the number for this one. It's a 0.01. Okay, the first one plus 0.077. Okay, 77 and 0.23. And the last one is 0.346. That give you P of 3. Okay, you add these numbers together and that give you the results. Okay, so it's going to be equal to what? It's going to be 13. You can use your calculator to get it. Okay, it's going to be 5, 7, 14. Okay, 14. And I get 1 back. It's going to be 4. Okay, 4, 6. I think that's 1. Check it with your calculator, make sure you get the numbers right. Okay, so that should give you 0.63. Okay, so 0.01 and plus 0.077. That was a problem that I just add recently, so I don't have the number. Let me check it. 0.346. It's 0.663, yes. So it's going to be 63%, I think. That's one. Okay, and you can double check it yourself to get these numbers down. Yes, that's correct. So this is going to be the case. Any question? And the last part is going to be probability of whatever. That was at most at least 2. So probability of at least 2 means x going to be greater than or equal to 2. Okay, at least 2. I use complement for this one so that you can see other options. Okay, when you're dealing with this type of problems. Okay, 2 means you can have 2, 3. See, you can go with the x greater than or equal to 2. You can go with the p of 2, 3. Okay, 4, 5, because you have to go up to the up to the 5. This is one option, and you already got the numbers. You can do it, or you can use complement if you like. Always you can use this type of ideas. Probability of x to be greater than or equal to 2, complement is the same as 1 minus probability of x to be strictly less than 2. Strictly less than 2 means 0 and 1. You cannot have the 2. So it's going to be 1 minus probability of 0 and 1. So just for, just letting you know that this is a possibility that we can have. So if you like it, you can use the complement anytime you like. So if you stay with the complement, this is going to be 1 minus p of 0. You already got the p of 0 here. Is a 0.01 plus a p of 1. You have that 0.077. Okay, so this is going to be another option. So if you stay with this one, it's going to be 1 minus. So this would be 7, 8, 7, 8 is 0 point. Okay, and if you, because that was 0.77, okay, that's 7, 7, 8. And if you subtract it, that give you 3. And that would be 1, 9 point. It's a 91.3%. That would be, the result of probability. So you have the option of the complement all the time. But since we're using the table, that would be easy just to, because as soon as you use the table once, then you'll be able to use it, twice quickly to get numbers. Okay, quite interesting one, but all this operation can be done if n is small. If n is going to be around 20 or most detailed. Later on, we're going to show you that what we are going to do when the numbers getting bigger and bigger. And then we are going to estimate it. Yes, the complement, yes, you know that P of A complement is 1 minus P of A. Remember the complement of complementary, what do you call it? Complementary rule of the probability. P of A complement is 1 minus P of A. It's always, because it's a leftover of the 100%. Leftover of the 100%, okay? So if the n getting bigger and bigger, even your calculator won't give you the result. But we are going to give you a method in order to take care of it in future. Okay, so that is the binomial distributions. So we talk about all type of discrete distribution, the binomial and the general one. Okay, any question? There is only one more formula for finding the mean, standard deviation, and the variance. We talk about it later. Otherwise, we are done with the binomial case. So let's go back. That was one type of the probability that we did have. Okay. So what is going to be another type of the probability? So we're going back. Remember the discrete one? All the information nicely given. They ask you the question like finding the mean, standard deviation. So let's do that one too. So this is one of those 11 questions on the find out. So the other one is, let's start with this one. Number 6. This is a discrete probability. Remember X and the PX. And the best we can do is we give you the situation and you are going to find the mean, standard deviation, and the variance for us. Okay, so it's a very standard question and try not to miss it. Okay, so I'm going to do number 6, discrete probability. Any question? So that's a binomial. It's a very special case, if you like, and you can't miss it. So going back to the number 6, this is what we talk about, the discrete probability. Okay, that's it. That is discrete probability. Okay, you have the X and the PX, and you want to find the mean, standard deviation, and the variance. You know that we give you 3 formulas, and then what you are going to do really, you just get the formula. You have to extend this table a little bit. Okay, I just want to bring the numbers that I have so I can take care of this one quickly. Okay, so let me just go back to that. My notes. This would be very easy problem. You can't miss it. For number 6, you want to find the mean, standard deviation, and the variance. You must know the formula. I remind you, 3 formula. The first one, mu, the mean. Sigma x px, that's the mean. Variance, sigma squared. Sigma squared is sigma of x squared px minus mu squared. And then sigma is just, the square root that give you the variance, the standard deviation. Okay, so that would be the mean. That would be the variance. And this is a standard. Okay, standard variation. 3 easy formula. So the table would be given to you as it's given to you. This is going to be, you are going to extend that table. So that's the X and the PX. This would be given. You multiply these two together to get the X PX. So you need one more column, X PX. You multiply by another X to get the X squared PX. X squared PX. This is how you design this table. Okay, the first 2 columns given, so I just repeat it. Number of the speak that the guy has, I think that was about the speeches. So X equal to the 19, this is given to you is at 20%, 20%, the chance that give 21 speeches is going to be 0.3, 30%. Okay, 22 is 20%. 23 is 10%. This is given to you, always would be given. You don't have to check it, it's already been checked, it's probability. So you multiply these 2 together to get the numbers here, okay? So 2 times 19, 19 times 0.2, you multiply that, give it 3.8. And you multiply by another X again, so the 19 times 3.8. So that gives us 72.2. That's the first column. Any question? You repeat it again for all of them, okay? Multiply these 2 together, that give you 4. You multiply 4 by X again, that give you 80. Multiply these 2 together, that give you 63 or 6.3. So multiply 6.3 by another X. So that give you 132.3. Multiply these two together, that give you 4.4. Multiply by x again, 22 times 4.4. So that give you 96.8. Then 23 times 0.12, that give you 2.3. We multiply by x, 23 times 23, that give you 52.9. That's it. You need this column, sigma xpx, you add them together. You add these numbers that give you 20.8, and you add these numbers that give you 434.2. That's it. This is all you need. So the number that you pick from here is a sigma of xpx. I just write it down to remind you. Is 20.8, and some calculator give these numbers right away. You can use those as well. So that is 4.2. So now use those top three formulas to get the result. Mu is sigma px. Mu is sigma xpx. So it's 22, that's a 20.8. That is the mean. Variance, sigma squared. I just repeat the formula. X squared px minus mu squared. X squared px is 434.2 minus mu squared, 20.8 squared. Use your calculator, the result should be 1.6. So the variance is 1.6. So that was the mean. And this is the variance. Of course, you take the square root. The square root of 1.6 is 1.3. Okay, so 1.3 standard deviation. Standard deviation. Okay, very, very easy formula, but make sure you get it right. That's one. Some people, they missed it because they used the wrong formula. In this problem, it was related to the what? It was related to the, there was a number of, there was a manager, there was a shop, and that was the number of suits that they sell, okay, weekly. So they ask you an extra question. The extra question is daily. I think that was daily. So the chance that they sell 19 suits, you know, for example, in a day is 20%. So what they want to do, you are the manager, you want to predict how many are you going to order for the next 5 days. You see, any suggestion? These are going to be the, you see, these are the number of the suits that you order or you sell every day. And these are the probability. So what you would like to do is you would like to order for the next 5 days. You are the manager. You want to know how many are going to order. See, this is the average value that you sell. So in order to order, you can pick this average and multiply by 5. Okay, so if you multiply 20.8 by 5, so that you 104. You know, of course, you know, run that if you need it, but you don't need this one. So this means number of the, okay, this is going to be the number that you have to order for the next 5 days. Okay, it's going to be number of. So they may ask you now a question, the comment. So it's going to be number of suits for the next, okay, for the next five days. So you have to order this number of the suit for the next 5 days to make sure that you know you have enough product, if you like, in your store. Okay, so don't miss it. It's easy question. Easy question. Make sure you give yourself a nice table. Okay, let's see it and use the correct formula and there to get these numbers. You have to find the mu and then minus mu. It's mu square. It's not mu. It's a mu square. You can bring any formula to the test, but make sure you bring the correct one. Okay, so I give you a short break. It's 11:21. We come back and we do the rest. Okay, there's one more problem regarding this one. You know that's a expected value. We take care of that one quickly, and then we go to the you have a multiplication rule and the conditional probability. Okay, you got 10 minutes, and then we come back and we finish. See you then. Okay, let's continue getting one more problem on the discrete probability. And that's problem of a discrete of the expected value. Remember, we talk about it, we do something and you have an expectation, mathematical expectation, which is going to be the same as finding the mean. The difference is going to be going to have only two options. It's going to be a procedure that you may gain or you may lose. So you have to design a table like this one and be able to find the expected value. So I just picked the one for the insurance policy that we have, that is number 7 on that practice one. We did this one, a similar one before. So just remind you that this is important question. Question number 7. And that's the one that you pay 100 and, okay, if you want to see the problem, this is what we have. So that's a problem number 7. Okay, problem number 7. Somebody pay $158 for the 1-year life insurance policy, coverage of $110,000. The probability that the person will be alive at the end of the year is almost 100%. What is the expected value for the insurance policy? Okay, for the insurance policy means from the point of view of the company point of view, okay, for the insurance policy. It doesn't matter, you can, from the person point of view, the person would lose money. From the insurance company point of view, they are going to make the money. So you have to design the table from the company point of view for this one, okay? So this is it. As we did it before, there is only a difference, and that's the point of view of a company, not the person involved. Okay, let's just explain the facts about this problem. So that would be number 7. You see, the situation is the person pay $158. Okay, that's the amount that the person would pay. And the insurance policy is $110,000. Okay, that would be the gain. And the chance that the person would be alive at the end of the year is almost 100%. Okay, so it's going to be is the probability or the chance? Is the probability. Okay, probability to be alive for a person. Okay, so what we'd like to do, we'd like to find the expected value. So it's going to be expected value for the insurance company, if you like. Okay, value for the insurance policy or for the company, if you like, insurance company. So this is how we are going to design it. You know, the formula is easy, just E equal to the sigma of x px. But you have to design it and give us a table of what's going to be a situation you're going to have. Okay, so this table would have only 2 columns. We did it before. So in this table, you are going to have the x is going to be the amount, the probability of x getting it. And this is going to be the company gain. Okay, and this is going to be the company loss. Identify this one and just the formula is already given to you. Okay, the point of the company, not the person. You see the gain of the company. The gain of the company is the money that you give to purchase the policy, which is $158. So that will be the gain of the company. Okay, the loss of the company. The company would lose the insurance policy, $110,000, but the company already got $158. So the company would lose 110,000 minus 158. Since it's a loss, we already talked about it, you have to identify it by a negative sign. Okay, any question? Now, what's the chance that the company will get the money? The company would get the money if the person would be alive at the end of the year. And the probability that the person would be alive is almost 100%. So the probability that the company would get the money is going to be 0.9994. The company would lose the money if the person is going to be dead. So the probability that the person is going to be alive is almost 100%, 0.99. So the probability that the person will not be alive is the complement, which is going to be 1 minus 0.994. So this is how we're going to design this table. Any question? So be careful. The other one we did was from the person point of view, remember, from the kind of Mike point of view, the one that we talk about it, but this is from the insurance policy point of view. So the company would get the money if the person going to be alive. The company will lose the money if the person is dead, which is going to be the complement. Okay, you can simplify these numbers and go to the table. So this would be, if you subtract it, that should give you a point, 0.0006. And if you get this one, the number is going to be negative 109,842. So get the expected value formula, E equal to sigma x px. So it's going to be equal to the x of 158 times it by the corresponding probability 0.994 plus the money negative 109,842 times it by the probability 0.06. So if you multiply the first one, that gave you 157.9052 minus the next one's going to be 65.9052. And the result is going to be 92. So the result is going to be $92. So this is going to be the gain of the company, average gain of the company from each person who purchased this policy. So on average, the company make money, $92 from each policy. Any question? On the other hand, the person, all those people would lose on average $92 when they purchase the policy. Okay, so it's not a difficult problem, but we need the table, remember, on the test. We need the table and then the operation that you are going to have. Okay, so that would be the second problem of this discrete probability measurements question. Now, we have one more here that it's a little bit different from what we did before. Just to remind you, in all these problems, x and the px was given to you. This is going to be another one that we are going to find this p of x yourself, okay? So let me explain that one too. Any question on this one? So this problem is going to be, just the first part is a little bit new, but otherwise it's like one of the problems that you did on the quiz. Let me see if I have it. Yes, that's problem number 8. Problem number 8, you see we give you a table. The table contains the x, the variables, and the frequencies, not the probability. Okay, and we asked the question regarding the p of x. So for this case, x is what? Is a number of somebody selling appliances such as a refrigerator, stoves, etc. X is the number of those things that we have. At the X is the number of the items, and the F is frequency of days which those items are sold. Okay, so for example, the frequency we have 9 days. Okay, in 9 days, they didn't have sell anything. In 72 days, they sell only one item, 62 days, etc. So it's going to be 0, 1, 2, 3 is going to be the number of the items, and the frequency, the number of the days. So what they ask you is use the relative frequency to find the P of X for this table. You see probability of getting the X. You don't have the P of X. This is the difference between this problem or any other problem that you're going to have. So in order to get the P of X, you know that they tell you that this is relative frequency probability. Relative frequency probability is the ratio of the frequency, remember, the frequency of each class divided by total number of the frequencies. So for example, if you want to find P of 0, it's going to be F, which is 9, divided by total number. The total number is 240. So you have to extend this table quickly to find the P of 0 to 7. Then you can easily answer this question that we have, okay? So the point is introduction of the P of X as a relative frequency. So I'm going to do it for you, or some part of this. So the trick, or the main part is the part that you are going to get that probability for us. Okay, so this is how we're going to do it. And it takes a little bit of time, but it's not bad. Kind of a straightforward problem. Okay, so what is going to be? I get the numbers here. Number 8. Okay, number 8. This is going to be number 8. Okay, I'm going to extend that. I need that table to be extended. So this is going to be the X and the frequency of the X. I need these numbers. It's going to be 0, 1, 2, 3, 4, 5, 6, and 7. This is one column. The other column is the frequencies. Frequencies are 9, 72, 63, 41, 28, 14, 8, and 5. Okay, so this is all you have. So what you need to do is you need to find the P of X. Okay, you need to find the P of X. In this case, P of X is a relative frequency probability is equal to frequency of the class divided by total number of the frequencies. Total number of the frequencies. Total number of the frequencies is already given to you. If you add these numbers together, that give you 240. Okay, so this is in fact is going to be F divided by what? Divided by 240. So P of 0, for example, is going to be P of 0. You see for the first part, I explained one of them. You see P of 0 is going to be frequency of a number of the days that they didn't sell anything. It's a 9 divided by the total one. You can simplify it, or you can use your calculator to give us the percent. So this is going to be the first part. And you just continue getting the other one. Okay, I write it down. You can simplify it yourself. So 72 over 240, the next one. 63 over 240. 41 over 240. 28 over 240. 14 over 240. 8 over 240. And the 5 over 240 give you all the probabilities that you need. You can simplify it, and write it down in percent. You can use your calculator. If you want to leave it as a fraction, you just simplify the reduced form. If you want to give us in percent, you just use your calculator to give us percent. We accept both of them. Okay, any question? So that's the first part, the main part for the probability. For all the other problem, P of X was already given to you. In this case, this is the way you are going to find it yourself. Okay, so that's a part one. Part two, they ask a probability question. Okay, part two. They ask you to compute the probability that X is between 2 and 5. 2 and 5 are included. So you want to find the probability that 2 is less than or equal to the X, less than or equal to the 5. Is a discrete probability, means the number between 2 and 5. So this means probability of 2, 3, and 5. That's it. You already got it on the top. You can add them together to get it, or just find this here. You see? So this is going to be equal to probability of 2 is 63 over 240. Probability of 3 is 41 over 240. And probability of 5 is, I'm sorry, I missed one of them. Yes, 2, 3, 4. I missed the 4. I need the 4 here. 2, 3, 4. P of 4. Have to pick all the numbers in between. Okay, so 63, 41. Then the next one is going to be 28 over 240. And the last one is going to be 14 over 240. 1, 2, 3, 4. 1, 2, 3, 4. Okay, probability between 2 and 5. 2 and 5 are included. Okay, so that's going to be 1. Now just use your calculator to get these two numbers and then we're done. Okay, so what's going to be the result is going to be 240 and you add the numbers together. Okay, that's going to be 12, 13, and 16. We have 1, 2, 4, 8, 14. Okay, that's going to be 12, 13, 16. Okay, and it's going to be 2, 4, 8, and 14. 146 over 240. Again, you can use your calculator if you are interested in percent, or just leave it as is, but you have to simplify it. Okay, so it's going to be 146 divided by 240. And that gives something like, almost 61%. Okay, so that give you the result. There is 61% chance that they sell something like, there is 61% chance that they are going to sell between 2 and 5 items, if you like. Okay, any question? So that's part B, and the part C. Probably that X is less than 3. Probably that X to be less than 3. Less than 3 means 0, 1, and 2, not 3. So it's going to be P of 0 and P of 1 and P of 2. Less than 3. And then you go back and you bring these numbers, the same thing. Okay, P of 0 is 9 over 240. P of 1, 72 over 240. Okay, 63 over 240. And you add these numbers and that gives you the final results. Okay, so it's going to be equal to, we get a 240 here, and that's going to be 514, 7, 14, 23. Okay, let's make it to the, oh no, 3 and 2 would be 5. 14, we get 1, 7, and 7 would be 14. That's it, that's the one. 144. Okay, because this is going to be, yes, that's a 72, and 72 is going to be 144. Okay, and you can divide it, and that's going to be 144 divided by 240, and that give you almost 60%. That's one that I have. Okay, so that give you an idea of how we take care of these type of problems to get these numbers. Okay, any question? So these are the collection of the problems on the discrete and the probability distribution that we talk about it. Okay, that will take us back to the rules that we have, conditional probability and the multiplication rule, which is very easy rule. So I'm going to get back to those numbers and explain a couple of more problems that we have over here. So that was, so we did the number 6, 7, 8, 9, 10, and 11. Okay, so we need a couple of more questions to take care of. The question that we have, question number 5 is the one that we did before, very easy question, and we can take care of it as well right away. Okay, so moving to the question number 5, remember, this is the one, exactly the one we did. We have a box urn, 17 balls in it with different colors. And that was multiplication rules in 2 different cases. Okay, that was the 17. Yeah, that is the case with the repetitions. So what we have in this case, you see, let me just explain it. That the number. So the case is that we have a box urn. So this is what we have. So inside we have a 17 ball. We have 6 reds, 6 red, 3 blues, I think 8 greens. So the total number of the balls are going to be 17. Okay, so what we pick, we are going to pick 2 of these balls. Okay, but in the first part we do the width replacement. So this means you check the color of the ball and then you are going to replace it. So we want to know, finding the probability that the first ball is going to be red and the second ball to be blue. Okay, so this is the question. You want to find the probability that the first one is going to be red and the second one would be blue. So since we do it with replacement, we already talked about it. You see, with replacement. So this means you return the ball, you didn't change the name of the game. So this means the events are going to be independent. You have to explain it on the test. The events are independent. So when the event's going to be independent, the probability of R and B is going to be probability of R times the probability of B. Remember, when it's independent, probability of A and B is probability of A times probability of B. So that's it, we find it. Probability of red, we have 6 reds, 6 out of 17. And probability of getting a blue is 3 out of 17. You cannot simplify it, so just multiply them together, 18 over 289, and in percent, 62%. So that's going to be the probability of getting a red and then getting a blue ball. But we did it with replacement. Any question? So you have to give us the formula, the reason and the reason. If you write only the numbers, you won't get total points. You get a partial points only. Okay, make sure you explain it. Second part, what we do is we repeat it again, but we don't replace it. If you don't replace it, you will keep one of the ball for yourself. So when we get to the second one, the situation is quite different. So in that case, the events are going to be dependent, and you have to use the, okay, same question in this case. But since you did it without replacement, without a replacement, is the same that we tell you that the events are dependent. Events are dependent. So you have to go and get the conditional probability format of the product rule, which is probability of R and B is probability of getting a red times probability of getting a blue one, but given that you already kept the red one. You see, that was the multiplication rule when the case are going to be dependent. Okay, because something else has already happened. You kept one of the ball. So this is going to be your formula. So the probability of getting a red is going to be 6/17 again. But for the second one, you keep one of the reds. Okay, so you're not going to have 17, you're going to have 16. But you want to pick a ball, blue ball, is going to be 3/16 this time. If they are going to be the same color, you have to reduce 3 into the 2 as well. Okay, and that's it. You can simplify it, multiply, or just multiply them together. Both of them would be the same. If you want to simplify it, you can simplify it by 2. That give you 3, that give you 8. Then you multiply them together. 3 times 3 would be 9. 8 times 17 would be 136. And if you use your calculator, that give you 66%. So the second part, probability of R and B is going to be what? Is going to be 66%. Okay, easy question, but you have to explain it for us. How you did it, or how you arrive at these formulas. Okay, that's number 5. The multiplication rule. Okay, question. Now we give you one question on the conditional probability, and you have 2 here. That would be very easy question, okay, to handle. So we explain it to see what's going to be the case. What's that? 6.6%. Just check it with your calculator, probably you're right. That's going to be 1. It may be 6.6. Yes, seems to be, yes. Okay, so check those numbers. So let's go back to see what else we can do for you. The conditional probability is going to be a very easy case because the situation would be nicely described, and you are not going to miss it. Okay, what's that? Just sharing this one again. Okay, the case for you see the case like this case number 4 that we have, or number 3. All of them are going to be the same thing. Okay, let me just explain number 3 first, as we have it here. You see a situation is given to you with this table. We have the range groups and their preferences for the drinks. And the total number is 255. You want to find the probability that the person is over 40 years age, given that they drink root beer. When you want to take care of this problem, as we talk about it, so what you have to do is, you see, find the probability that a person over 80, given that. So it's conditional probability. This part, which is a given that, we are going to call it B. Okay, we are going to call it A, the given events. And the other part would be B. So this is going to be the way we're going to organize it. And then the formula is going to be very easy to handle. So this is how we are going to get this one done. Okay, so for this number 3, and then number 4, just make sure, you put the numbers in the proper place. You see, formula for the conditional probability is this one. Probability of B given A is equal to the probability of A and B divided by the probability of the probability of given one, which is always A. Call it A so that you are not going to be confused. So A is the given event. Okay. So in this problem, you see the situation is that I write it down, so I explain it. You see you have the probability. You see the probability that the person is over 40. Okay, given that, you see this part is important. Given that they or he, they drink, okay, they drink root beer. So the way you identify this one, the given event, always you call it A. Always. The leftover, you call it B. You see, this is the way you're going to set up your problem. Always the given, call it A, the leftover B. Now, just operate with your formula. So the formula that you have is going to be what? Now the probability of B given A is going to be equal to, you see there, I repeat it again, is probability of A and B divided by probability of the given one. Now find each probability. The total number is 255. So what you need to do is you just read these two together. What is the top one? The probability that the person is over 40 years and drinking root beer. Okay, the person is over 40 years old and drinking root beer. If you go to the table and you look, that number is going to be 30%. Okay, you just put them together, divided by the given one. The total number who drink root beer, and these total number are going to be, you have a 25, 20, and 30. If you add them together, divided by 255. Okay, so this is going to be 30 over 255. Okay, and this is going to be 75 over 255. You simplify 255 and 255, that give you 30 over 75. And you can simplify it by 5 or by 15. So that give you 2, and that would be 5. That give you 40%. So the probability of B given A is going to be simply equal to 40%, and then you're done. See, it's easy problem, but make sure to get the formula. You have to explain the formula for us. Always identify the given probability as A, the leftover as B, so you don't have to switch your formula. You just use the same formula for all the problems. And then when you want to put the top one, just check this one, that the probability that the person is over 40 and you put them together and drinking root beer. Okay. So you find the numbers from the table and just simplify it, and that give you the final answer. Okay, that's number 3. Any question? Number 4 is very easy. I just explain it quickly. All the information is given to you. The information you have that we check a number of the houses, we find out that 42% of houses, these are going to be the house having a deck and garage. The house have a deck. Okay, have a deck and a garage. 60% is the fact that the house have a deck. Okay, this is a situation. So what's the question? The question is, would like to find the probability. I just write it down again. Find the probability. Find the probability that, okay, that the home has a garage. Given that, okay, given that it has a deck. You see, read the question carefully. Change it to the notation that I'll talk about it. Given events would be A, and the leftover would be B. So what's the question? The question is probability of B given A. But make sure that your notation are consistent, okay, with the information that we have. So it's going to be probability of A and B divided by probability of the given one, which is A. And if you read the problem carefully, you find out that both numbers are already given to you. You see, what's the top one? Read this one. The top. A and B, probability that a home has a garage and has a deck. Garage and deck together, it's already given to you. It's 42%. So the top is going to be 42%. Okay, 42% on the top. Given that, what's given that? The probability that the house has a deck. House has a deck, 60%. That's it. You know that you change the percent to the decimal, it's going to be 0.42. And it's going to be 0.60. And you know, we can drop the decimals divided or just use calculator. Like 42 over 60, 710, which is 70%. So probability of B given A is going to be 70%. And you're done. Again, it's not a difficult question, but some people, they're confused with the notation and the way they write it down, but the key is really this one. Get the expression that you want to calculate, okay? Call the given events A, the leftover B all the time. Then you read them together and that give you the final answer, okay? Won't get time to get that problem 1 or 2. There are different ways to do two problems. We can discuss this one after your test. I don't want to rush it. You can do it by binomial distribution. It's not a difficult problem. But we can discuss it later on that we need it. Okay, so that's it. This plus, remember your quiz. And in your quiz, we talk about the box plot, you know, outliers, and the the probability problem, okay, those decision making, and the addition rules. So put them together, you should be fine. And I post a take-home one for you so you can practice more before getting the test. That's it. And you know that no class next week, but when we come back, we give you the test. Okay, so we have enough time to practice and study this one, and you should be fine. Okay, so I post a take-home one for you that give you extra points. That will be good for you. But and you already got the practice one. Okay, any question?
Professor, I have a question.
Yes.
So I noticed like in the Canvas gradebook, it only shows only the quizzes, the tests, and the take home, like the extra credit ones. So
Yes.
will the homework be counted all the way at the end of the grade after the final?
That's it, yes. Yeah, because I have all of them. Yeah, before the final, you will get when your homework is done, then we give you the points. We check over all your activities, then we give you the points. Yes. Any more question? That's it. Have a good one and have a nice break. But prepare for the test. It's a good one. Try to get an excellent grade on this one. Test and number 3 would be a little bit more involved, would be of the type that we are doing it, like a binomial discrete one that you'd see. It's more algebraic one. It's going to be a little bit more involved, okay? But you have a good chance to get an excellent grade on this one. And of course, you can drop one test. It's going to be there, this one. But whatever we do on test 3 would be repeated on the final right away, okay? And from all these that you did so far, there's going to be only 2 questions on the final. So rest of the course would be the one that we are going to be dealing with for the final. Okay, no, I'm not going to post any more solutions. Question number 1 and 2 is not going to be covered. It's very easy, but I have to explain something that I didn't do it. So you can drop that 1 and 2. Okay, that's it. Any question? Okay, have a good one.
Thank you, Professor. Have a nice break.
You too. Thank you. If you need anything, just email me. Bye-bye.